I want to go back to the fearless, the first one, better understand that. I mean, how do you know, like, how do you know which problem to pick up? There's so many, right, technical problems out there waiting to be solved. So how do you decide which one is worthwhile for you to be fearlessly resolving it?
So in the past, before we were acquired by Google, a lot of the direction was applied by our customers. I like to think of it as though here's one vector, which is what we wanted to do. And we would find customers, some of them wanted to do what we wanted to do. Some of them wanted to do other things, but thought we could do it. That's not a good situation. The best situation is alignment. And then our job was to find a set of customers where there was enough mutual direction in what they wanted and what we wanted so that you could make progress over the long term, not just in the contract, not just in one project, but over many projects. So I think that's the way we thought about it. Sometimes when things were a little rough, we would take a project that not only did this, but sometimes even, set us back because we couldn't work on what we should be working on, we thought. In our current situation, at the Institute, where we're completely funded by Hyundai, and Hyundai is a great owner and partner in the work we're doing, we have a lot of freedom. And it's scary freedom. It really requires fearlessness because we have to pick a direction that's going to be at least we can pick several directions, but some of them have to pan out. It's a little bit like being a venture capitalist. You don't just bet on one company, you pick a portfolio of companies. And that's what we're trying to do now, pick a portfolio of thrusts, not spread too thin, but with the right mix of risk and opportunity across the various things we're trying to do.
Yeah. So let's maybe pivot, talk a little bit about your most famous celebrity robots. For example, I'm familiar with BigDog, Spot, those are the legged robots, and Handle, which has a wheel, right? And then Atlas, which is a humanoid research platform. So first of all, who gave them all the names?
I did BigDog. I think Al Rizzi might have done Spot. Spot's from the children's storybook. So that's where that name came from. I don't know exactly who picked it, not me. Handle, Handle was designed to handle objects. So Handle was a derivative from an earlier version of Atlas. Mm-hmm. It has some of the form of a humanoid, but it's simplified. And we were trying to make it more practical so it could handle boxes.
Could you also walk us through the latest product family and their targeted applications?
Well, when I look at Spot, it's a robot that you can buy today. And as I said, there's about 1,000 of them out there. Some of them are used. There's about 100 universities that have them. There's a couple of high schools that have them. There's a lot of innovation labs at companies that use them. And then there's a core set of customers using them at factories, refineries, places where they need to do inspection to look at gauges, listen to machines to make sure it's working. And, it's kind of a tedious job to go around and do all the measurements that need to get done. And the idea is that by using Spot for that, there's a real commercial opportunity to scale up the uses. And we've been working on the reliability of the robots, and we have them now so that there's several hundred hours between interventions, and they're really practical for those kinds of applications. But I call that a today robot because we're selling it today. The stretch robot, which is one that handles boxes that are about this big, most of them are cardboard boxes. And, most of the world's products get manufactured, they get shipped via a truck or a boat in a container. And then they get unloaded from the containers, they get resorted and put back on trucks or on containers, and then get shipped to retail stores. And almost all those handlings and there's about 500 billion boxes moved around the world every year. That's a big number. Mm-hmm. And almost all of it's done by human hands. And it's not always pleasant work. It's really backbreaking work, where you're doing repetitive operations, box after box after box. So we designed Stretch, which is the derivative from Handle, which was a derivative from Atlas, to do this task. And we're selling it into people who have warehouses who are in the middle of that process. And we have a group of early adopters. So we don't have Stretch is still in a prototype form. We're going to have the first actual product next year, but we have them in trials in real working warehouses today as the prototype. So I call that the tomorrow product, because next year sometime we'll actually be shipping it at reasonable scale. Now we're working with a handful, I think it's 6 or 8 visionary large companies who have a big warehouse need. And then there's Atlas, which is a research platform. We don't have any immediate commercialization plan, but it lets us cultivate new technology for controls, for design. And, I think there will emerge from it future products before long. The next time we do an interview or you do an interview with another Boston Dynamics person, they'll be ready to tell you what's next after Stretch.
Back to Spot, I remember we had this conversation about how big the Spot should be, how much weight it should be. So what is the perfect weight you picked?
The size of the current one was actually suggested by Larry Page when we were working at Google. We had a larger one that was about 125 pounds, and we demoed it for him and for others there. And at a meeting, he said, well, if it weighed more like 60 pounds, then you wouldn't be afraid to have it in your house or work closer in an office or something like that. So we said, okay. And we did a precursor to the current commercial one that was about that size. I think it might be a little overweight now, but it's very close to that 60-pound scale. And there's some other people out there developing robots a little bit like Spot that are a little bit smaller. Mm-hmm. And I don't know if we'll do that or not. We, meaning Boston Dynamics, will do that or not, but it's possible.
So it really depends on, I guess, the environment and application that kind of determine the perfect size.
Yes. There was one other thing that influenced the size of Spot, and that is we wanted it to be able to reach onto a counter, like a kitchen counter, and be able to reach the back of it. So that meant it needed to be a certain height, and the arm had to be long enough to do that. If it weren't for that, we might have made it a little smaller.
Mm-hmm. So how would you summarize the key learnings from the past 30 years, Marc?
I think it's really good to be intrepid and, to keep going in your direction, no matter what the external situation is. Stick to what you love doing. That's obviously the biggest thing that not only applies to this, but maybe for other parts of life.
Such as the Hawaiian shirt fashion, right?
I think it works for me. Who knows?
So what's your vision for Boston Dynamics in the next 30 years?
Well, I think Boston Dynamics is really in good hands. And that means a combination of Rob Plater, who's the CEO, whose goal is to really make it a commercial success, and in the hands of its owner, Hyundai, who has been just a fantastic support, both believing that future technology is important for them as a company. You could look at them and say that they're a traditional car maker, even though the cars they're making now are getting more and more modern and futuristic and are doing, very well in that regard. But their leadership, starting at the top with their chairman and down, are real enthusiasts for future technology and bringing that in. And that's why they support both Boston Dynamics and the new institute that I'm working on. And so I think that's a great pair. Also, a company like Hyundai that manufactures millions of cars a year is a great partner for a company like Boston Dynamics that's designing new technology that needs to get manufactured at lower cost and at scale. And I think there'll be a lot of symbiosis there.
Mm-hmm. What advice would you give the younger self 30 years ago?
I would say, stick with it. You're doing a good job. I don't think I knew that at the time, but that's what I think now. keep going.
Any advice for like young engineer or future entrepreneurs?
I would tell them what I said before, that well, this is more for engineers, that it's a great field, that they're lucky to be doing what they are, and they should if they're not relaxed and having fun, they should. Don't worry, and do what they love doing.
Mhm.
Entrepreneurs, I I have a mixed attitude towards entrepreneurs. I think there's some who want to make a quick buck and don't really want, or it seems like some of them are flitting from one thing to another, and that doesn't inspire me very much. Uh, of course, there's some who are, very serious about what they're doing, and very thoughtful and all that.
Mhm. That leads perfect to sort of the next topic I would like to discuss with you. According to your LinkedIn profile, you studied electrical engineering at Northeastern University and then earned a PhD degree in philosophy in MIT. So electrical engineer was expected, but I'm curious about how philosophy related to robotics.
It's not philosophy; it was psychology.
It's a psychology. I see. Wow.
Yeah.
But how did that happen? And then, related to the robotics, if anyway.
Well, even though that department at MIT, which we call Course 9, if you're an MIT person, you name the departments by number. That department had two parts. One part that was probably what you think of as psychology, which is, how does the mind work? How do you use language and things like that? But part of it was neurophysiology, and doing things like recording from the brain to figure out how eye movements worked, how you used your hands and arms, how you balanced yourself when you walk, because animals do all these things. People and animals do all these things. So it really wasn't any different than robotics. It was just looking at a system that already solved all the problems that we want to solve for robotics. So that really fits in perfectly. Now, partway through studying the physiology of animals and people, I took a turn at MIT as a graduate student and started working on robots. But I stayed in that department until I finished. And then when I went back as a professor, which was several years later, I went back to course 6, which is electrical engineering and computer science, which is a little more squarely focused on building, machines that have the same characteristics that people and animals have.
Mm-hmm.
So there wasn't as much of a crooked path as it might sound like.
Yeah, it's just I guess there's a good reasons behind what happened. Eventually, right, come together.
You asked about turning points. There was one other turning point. When I was studying neurophysiology and recording from animals, I didn't really like it very much. And I took a course and I followed the professor back to the lab. And at his lab, there was a robot arm taken apart, lying on the table in about 1,000 pieces. And when I saw that, it was like I was in robotics from that day on. No, there was no turning back.
I see. Your story actually may give a lot of comfort for a lot of younger generation of students in the university, because I got a lot of questions. I'm sure most professors get those questions. What should I do in the future? They're smart, they're brilliant, they work hard, but it's just they need some direction, right, to move forward. What you just said, I think it's probably happened to most of us is, yeah, we wish that we knew, 30 years ago when we were in college, exactly what we wanted to do. But I guess curiosity led you to, where you are today.
Yeah, I think people should do what they really like doing and not let people tell them what they should do more than necessary. They should really do what they love doing if they can find a way, to succeed at it.
Yeah, I love that. I would also love to ask you a few questions to just better understand your approach to research, to development, and innovation. First of all, after working at a Google X and many moonshots projects, that takes a long time, right? I realized the challenge related to long-term R&D projects. People are passionate about working on complex problems to change the world and make an impact. but we had to cancel most of the projects for good reasons. For example, technical feasibility is not ready, economic viability does not look good, or we're ahead of time. So what is your view about short-term success versus long-term goals?
I love the phrase stepping stones to moonshots. Google is famous, Google X in particular is famous for talking about moonshots. But I think that you only get moonshots if you design things so that they're stepping stones. Where for me, a stepping stone means, even if you're working on something that might take 10 years, a stepping stone is a 1 year or 18-month, a year and a half project where you're not hoping to get everything solved that you're working on, but you hope to make progress towards it. And getting part way really accelerates the longer project because you get partial feedback, so you can do course correction. You always learn from implementation, even if it's not the right one. So we like to think in terms of designing stepping stones where you have tangible results that are sort of put into enough of a realistic form so you get some sense of how it's going to work when you get into the larger world of application or testing. Sometimes you'll cheat on, cheating isn't necessarily a bad word. If you have 5 components that are needed to solve the problem, here's your problem, and there's all these different components. It's okay to have some of them very ragged solutions, or you have a person doing the solution rather than automation if you're talking about robots, so that you can develop some of them. And then, one stepping stone is to get these working, and then the next time through, you'll get these working, or you'll fix the things that weren't working before. So, there's incremental ways of making progress on non-incremental problems.
Yeah, I think what you said was the short-term tangible results or wins, right, are important to have a long-term, I guess, big impact.
Yeah, I mean, they're also important emotionally. It's hard to work on something where you don't get feedback and satisfaction for a very long time. So you want to find ways, to have fun all the time.
Yeah, that leads to my actually next question is, many people motivated by impact, right? So what's your philosophy related to, like, regarding to R&D project that may or may not apply to the real world? How do you measure success that way?
Well, this is relevant to the current endeavor because we don't plan to have products maybe ever. And I think it's a strategic decision to reject commercialization, because commercialization pushes one to work on shorter term needs, like putting in the features that a particular customer needs so that you can get revenue from them, or working on reliability when you don't have the core functionality to where it needs to be. So our goal at the New Institute is to work on more fundamental problems that are harder, to get more bold solutions that'll take us to the next generation. And you can point to cases where this has paid off. I think Tesla, it took about 10 to 12 years to get from the Roadster, which wasn't really a commercial product. I don't know how many they sold, but to the Model S, which was the place where they had success. And they learned a lot during that period, and they refined things. And I would say that was an example of how you bring technology along. I think the time horizon for robotics and AI is even longer than that. And if you look at organizations like DARPA, who have, I think of it as keeping the ember alive. If you look back 30 years ago, or you could go 40 years with me, because I was doing university DARPA funded work on things a lot like the robots we're building now, but not mature at all. You couldn't do that with venture capitalists. You certainly couldn't do it with your own money. You had to have an outside way of keeping that going. And the government was interested in cultivating technology over the long haul. And that's a great thing for the United States and the world, in my opinion.
Mm-hmm. So how do you motivate yourself during that long period of time, and also your people, right? Just keep going regardless what short-term outcomes might be.
Well, I think you make the short-term outcomes enjoyable, and either by, as I said, being an engineer, you get to have the fun of building stuff. You get to show off results. YouTube was a great invention for me personally. I think if we had taken my early work in robotics and just written scientific papers where you plotted data and maybe showed a photograph or two, it wouldn't have had anything like the impact of showing the robot stumbling around or not stumbling around when we were more successful or whatever it was we were doing. And although we had video and film in the early days, YouTube sort of was a wave that we could catch because, you could very easily show thousands of people what you were doing.
Mm-hmm.
In the early days, when I was a student, we were taught to shun the media, that there was no upside to talking to the media about what you were doing. And as a professor, there's still some truth that that you don't want to go overboard with the media. But once we had a company, there was a time when I was trying to sell a project to a government group, and we'd been working on this group for probably close to a year with no progress. And then one of the program managers and his wife were at home watching National Geographic, and I was in some scene, showing off an early robot. And about 3 weeks later, I had a contract. And
Wow.
as a company, there's a great power of being seen on that platform.
Mm-hmm.
And YouTube is a platform that makes it so you can do it without having to, get the media establishment involved in the process, which is a great tool.
Yeah, so YouTube give you the control over your message, your story,
Right.
Yeah, I see. What about the winning company strategy in the next 30 years? For example, there's a popular like platform versus product, the hardware versus software, and many other, combination could be. What are your thoughts?
You're asking the wrong guy. What I want to do is have a group that creates the technology that's going to enable the future products. And it's going to be up to the investors and the marketeers and the business people to harness that technology into products. But I think that if we didn't do what we want to do, which is to, make the technology, let me circle back. The key thing we want to do is make robots smarter, more like people. People, you can point at a task and say, see what that guy's doing over there? I want you to do what they're doing. And the person can perceive what they're seeing, translate it into a sequence of steps. They understand what the steps are, and then do it themselves. Now, they may have to learn a skill that they don't have. Sometimes they can figure it out just by watching. Sometimes they'll already have the skills. Robots are nothing like that today. You have to have a whole room of programmers programming the skill, programming the sequence, adjusting it to the environment, building perception so it can see the things going on. And I think there's a lot of ways that people are very smart in a way that we take for granted that we're trying to build for robots. And then once you have that, I think robots are going to be much more useful. There'll be a lot more products you can do with it, a lot more valuable, increase productivity, increase safety. It's going to be a great day, but there's some hurdles to overcome to get there.
Mhm.